Hello sir, my name is Parusha and this is my video demonstration for Lab 10 where I used NASA Access Log dataset to perform anomaly detection using the Elasticsearch. So let's start with the task 1. So first task 1 was to import the NASA dataset and convert the timestamp. So I used a Python script which converts the timestamp into ISO-8601 format, which Elasticsearch, like, it's a standard format for Elasticsearch to accept, and saves the output in data underscore converted.csv file. So once the data was cleaned, I uploaded into Elasticsearch using the upload file option. So Elasticsearch automatically create an index and for me, and it will rename it with everything. So I ingested my data set using the logstash configuration. So here it's saying the file input where my data is saved, starting position, beginning, and I am using the field separator, which is this, and I have the columns over here, and I am specifying the status as an integer and bytes are in integer numbers. And here is what I did for my Python script. So here is the timestamp, and this is the other configuration for Elasticsearch, and the index will be named as a NASA access log. So let me start running this. So it will ingest the logstash will now ingest all the data set into the ELK stack. As you can see over here, so the data is now getting ingested over here, and if you quickly see, oh, it's just pushing up because I have a lots of data over here. So let me open my Elasticsearch. Give me some time, sir. So now I'm stopping it, and yes, this is my Elasticsearch. And if you show me, if I'll show you the Elasticsearch, so I have like all the logs over here, which is for the task 1. So now task 2 was to verify the index and all the stuff. So for stack management, and now I'll go to the index manager. As you can see over here, my index is already over here with name as NASA access logs and all the stuff over here. And if you want to see the template, so this is the indices of all I am having data streams. As you can see over here, if I click over here, so I have all my mappings over here. So this is the mappings I'm using it, statistics and settings all of over here. Now let's move on to the third task, which is creating a 3ml anomaly detection job. So for that I used ml over here, and as you can see over here, wait, jobs. So as you can see over here, I have all the 3 jobs here created. First one is NASA distinct host single matrix, second is NASA high traffic host, and third is NASA traffic single matrix. So what I did here was actually I created the NASA distinct host single matrix. It detects unusual spikes in distinct host over the time. So as if I open my here, you can see over here, if I open over here my detection and I'll change my timestamp. So see, as you can see over here, it creates an usual for the anomaly detection for single host. As you can see over on the third 1995, there was a severity level was 98%. As you can see over here with the timestamp. Now I'll change it to the next one. So next one is high traffic one, host one. So let me open this one, change the timestamp. So as you can see over here, there are too many IPs over here. So it detects the HTTP traffic behavior using a single matrix. So here, as you can see over here, it's showing the different kinds of IPs which are host, like checking the HTTP over here. And as you can see over here, there are some severe as well. On August 22, 1995, there was a 99 severity level, and it's showing all the descriptions over here. And the third one is single matrix. let me go through the single metrics as well. So this is my third one, and it's get already run and it finished it task. So as you can see over here, so the single matrix which detects the abnormal HTTP behavior using a single matrix. So after each job, I started the data feed and let the Elasticsearch analyze the traffic from July to August 1995. And now let's see the anomalies found over here using the visualizations later on for the task 4. So let's move to the task 4, which is a visualization for my lab. So this is my first visualization, which is the critical visualization. So I created a 3 visualization: minor anomalies, major, and a critical ones, and each visualization using the NASA traffic metrics as their baseline. And the vertical lines here are showing the ML anomalies via ML anomalies index. So as critical indicates the red color, major indicates the orange kindish of color, and the minor ones is yellow color. So what the critical anomaly is explaining over here. So the graph here clearly says the critical, and it's very high and indicates a very severe abnormal activities. Why? Because on, as you can see over here, it's showing very different kinds of traffic going on. And as you can see over in the like task 3, it was a large spike on around here. As you can see over here, on large strike over here, 10/7/1995 scores the almost kind of 97 percentage, which marked a deep red, as you can see over here. And also on August 12th over here, it's having a huge spike over here. So the red background helps to highlight the severity. And now let's move on to the major one. So the major ones here is less severe than the critical, but still significant. So severe ranges between 50 to 75, and we strongly see the July 10, as you can see over here. July 10 over here is like again around July 10 and again on the 21st, as you can see over here. So it's showing the highest, and these anomalies suggest abnormal but not extreme traffic behavior. And now let's move on to the minor one. So the minor here meeting the small deviations from normal traffic. So the major anomalies appear frequently because small fluctuation in web traffic are normal, and these are often fall in between 0 to 50 severity range, and the many minor spikes appear daily due to a natural variation in the request volume. So now let's move on to the task 5, which is like combined heat map for all the jobs together. So if I open my, just give me a second. Give me a second. Yes, as you can see over here, the big picture for my heat map, where the final visualization I created the heat map using the combined 3 ML jobs in a single matrix. So on the left hand side, as you can see over here, there are 3 job names over here: distinct host, high traffic host, and the traffic in all over here, which is over here in my job ID. It's selecting the all the jobs from here. And on and also you can see over here all 3 over here on the left hand side, and on the right hand side it's showing the severity. So dark blue is normal, as you can see over here. Dark blue is normal, then light blue is little bit severe, this is normal, this is little bit severe, then yellow over here, yellow and orange is like medium severity, and red over here is the critical, like severe. And the heat map what expecting here is the red block on 29th, as you can see over here. It's also 29th one. So the here is also the 29th one. So the heat map on 29th and 21st August shows the severe anomalies. Orange block represents the major anomalies, and the most days remain blue, which means the normal traffic was going. And the visualization allow us to compare how same time period triggers the different anomalies using different ML jobs. So finally